We know our lakes, our rivers, our streams. It's easy to understand the importance of the freshwater tonga that lie at the surface of our planet. But hidden beneath the ground lies water that's critical for our freshwater security. This groundwater is closely connected to the surface water and provides up to 80% of the flow that we see at the surface. We rely on groundwater to drink, we rely on it to irrigate our crops, and we rely on it to maintain the health of our rivers and streams. We really need to know more about this critical resource. SkyTEM allows us to sneak a peek. It allows us to see the extent of that hidden groundwater resource.
We can use these SkyTEM data to help understand where groundwater is stored, how it's flowing and where it's flowing, and also how it might be interacting with surface water features like rivers and wetlands. SkyTEM is an airborne geophysical system that uses electromagnetic technology. SkyTEM gives us electrical voltage data, and that tells us how easy it is for the electrical current to move through the ground. That electrical current is sensitive to a number of things like geology, water content, porosity, permeability, and that helps us understand the properties of the subsurface from 0 to around 300 to 600 metres depth. Because it's helicopter-borne, it's a very fast and efficient method for collecting data, and we can cover really large areas quickly. Typically, for understanding groundwater systems, we do things like drilling boreholes, taking water samples to understand things like chemistry and age, but all of these systems only give us really point information. What SkyTEM does is it helps us really fill in the picture between those points and gives us a more full and 3D understanding to figure out what's happening between boreholes or between water samples. At GNS Science, we have a really cutting-edge groundwater numerical modelling team, and that's allowed us to test different methodologies of bringing the SkyTEM data into these models to best reduce uncertainty.
These numerical models are used by regional councils to help them make groundwater management decisions. We know groundwater is only going to become more critical as climate changes and rainfall patterns shift. The SkyTEM data and models are critical tools to ensure sustainable management of this precious resource.
We've collected SkyTEM data in several regions in New Zealand already and have over 25,000 kilometres of data, and we've got plans to fly more regions in the future. Every region is different. They have different geology that hosts their groundwater systems, and they also have different challenges that they're facing when it comes to groundwater. We're working closely with each different region to understand what their priorities are so that we can produce models and outputs that are really fit for purpose for them and their decision making. For the Hawke's Bay region, we've developed an Esri story map to communicate the outputs of the project and also make the 3D models accessible. And we've worked with Hawke's Bay Regional Council staff on this project to make sure that the models and the data sets are fit for purpose for their needs, that the models are accessible for them and in a format that they can easily use for their own work.
We've already covered a lot of ground with this technology, but there are many more regions where we still don't understand enough about the groundwater system. By flying more surveys, we can strengthen New Zealand's groundwater resilience.